Hello again, welcome to another lesson in geometry. Today we are covering Chapter 1, Section 7, Midpoint and Distance on the Coordinate Plane. Alright, so we had a warm-up first. It says, using only a straight edge and a compass, construct a triangle whose sides are all the same length. So please try this yourself first, and then come back and you can see how I did it, and make any corrections that you might have. So remember, we're not measuring with our ruler, we're just using a straight edge which would normally have no markings on it. All right, so I'm just going to start by making one side of my triangle, okay? And we'll make it a little longer. All right, so now what I need to do is take my compass, put the pointy end on one side, and then I'll open my compass up to the whole length of the line segment. All right, at this point, I'm going to draw an arc, and let's see, up above the line segment. All right. Then I'm going to put the pointy end, without changing the settings on my compass, on the other side of the line segment. And once again, I'll draw an arc here. Okay. This point up here should be the same distance as our two segments here. Now, I'm going to use my straight edge to connect them, and I'm done. All right, so here is a triangle whose all sides are the same length. So this is called an equilateral triangle. Remember this from 8th grade math, okay? So any triangle with all the sides the same is an equilateral triangle. By the way, all the angles would be the same also. All right, so here's another problem on the bottom here. On the number line above, point P is at -3 and point Q is at 5. Find the midpoint of PQ and graph it on the number line and label it point M. Okay, so let's see. Midpoint should be midway between P and Q. So I'm just going to count up how many spots there are. So that's 1, 2, 3, 4, 5, 6, 7, 8 spots in between. So if I count 4 over, 1, 2, 3, 4, I could find the midpoint M. Okay, so how did you find the midpoint? Possibly you did something different. Okay, but I just figured out where was the middle by counting. All right. Okay, on the second page we have midpoint formulas. In this case we have formulas because we're going to find the midpoint on the number line like we did before. And we're also going to find the midpoint on the coordinate plane, so in 2D space. All right. So description, on the number line of the coordinate, the midpoint is the average or the mean, arithmetic mean, of the coordinates of the endpoint. So the coordinates of the midpoint M of AB is AB divided by 2. So A plus B divided by 2. So for instance, on the number line, if we had a point at 2 and at 6. Now we all know the midpoint should be at 4 now. Okay, but it'd look like this. We would say 2 plus 6. And then since they're two numbers, we divide by 2. And 8 divided by 2 would make 4, which is our midpoint. All right. All right, in the coordinate plane, the midpoint are the coordinates are the average of the x coordinates and the average of the y coordinates. So the same thing, we're going to do the mean, but we're going to do the x's and y's separately. All right, so let's say we had a point at, I'll draw this a little differently. Let's put a point at 0, 0, and then a point at 5, 5. Okay, and if we want to find the middle of this, it makes sense that the middle would be 2.5 and 2.5. That's halfway in between of each. And the way you get that is by doing the 5 plus 0 divided by 2 for 2.5 and 5 plus 0 divided by 2 for 2.5 again. All right. So our second question here was asked to redo problem number 1 from the other page using our formula. So P and Q are at -3 and 5. So if I go back here, our midpoint formula is going to be -3 plus 5 divided by 2. -3 plus 5 is 2, and 2 divided by 2 is 1. And we can see that 1 is the place we put our midpoint. Okay. All right. EF has endpoints at 7, 5, and 2, -4. So graph and label EF, and then find the coordinates in the midpoint of EF, and then graph your label your midpoint. So first we're going to graph and label E and F. So that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. There's E at 7, 5. And F is at 2, -4, so 1, 2, and 1, 2, 3, 4. And there's F. So here's our line segment, EF. And we need to find and label the midpoint. Okay, so first off, we'll find the x coordinate of our midpoint. So our midpoint is going to be, it's going to be at, let's see, 7 plus 2 divided by 2 for the x, and 5 plus -4 divided by 2 for the y. It's add the x coordinates, 7 and 2, and then divide them by 2. That's how you find the average of the x's. And then add the y coordinates, 5 and -4, and divide those by 2. So 7 plus 2 is 9, and 9 divided by 2 is 4.5. And 5 plus -4 is 1, and 1 divided by 2 is 0.5. So you're not likely to have eyeball guessed where that's supposed to be. So our midpoint should be 4.5 over. So 1, 2, 3, 4.5 over, and 0.5 up. So my EF is not very accurately drawn. So let's see if I can get this midpoint in the right spot. 1, 2, 3, 4.5, and 1/2 up. So it should be right in the middle there, which means EF should have gone through that red dot. Okay. All right, so hopefully you did a little better with the straight edge on your graph. Okay, so on our third page, we have some more practice on midpoint. So JK has endpoints at -12 and 4 on the number line. What is the coordinate of its midpoint? So it would be like over here, at -12, it's -8, -4, 0, and then 4. So we have a point here and here for J and K, and we want to find its midpoint. Okay, so to find the midpoint, we're going to do -12 plus 4 divided by 2. So -12 plus 4 is -8, and divided by 2 is -4. So our midpoint would be right here. That's our midpoint at -4, okay, which is 8 away from each one, so it makes sense. All right, so what is the midpoint of RS? It has midpoints 5 and -10 and 3, 6. Okay, so this time for midpoint, we're going to find the average of the x's separately. So 5 plus 3 divided by 2. And then the y's separate, -10 plus 6 divided by 2. So 5 plus 3 is 8. So our midpoint is going to be 8 divided by 2, which is 4. And -10 plus 6 is -4. And -4 divided by 2 is -2. All right, number 6 is a bit different. We know the midpoint, and we know one of the endpoints, and are asked to find what is the other endpoint. So this problem is a bit trickier. So to find the x of the other midpoint of the other endpoint, what we're going to do is use our same formula to find the x coordinate of a midpoint. So our midpoint x, we already know, is -2, and that should have been equal to one endpoint's x plus the other endpoint's x. We don't know what it was. You'll see in the book they're going to put x1 here just for a coordinate x1, because this is the x coordinate of the D. And then we're going to divide that by 2. So we have to solve this for x to find the x coordinate. So I'm going to multiply both sides by 2 to get -4. Remember that big bar is a grouping symbol. We have to do it last. And then we're going to add 5 to both sides to get 1. So now I know my x coordinate of D. So D has an x coordinate of 1. And then I need to find the y coordinate. I know the y coordinate of the midpoint, that's 1. And that was found by doing the y coordinate of one endpoint plus the y coordinate of the other endpoint and dividing by 2. So I need to solve for y. I'll multiply both sides by 2. Okay, then I will subtract 7 to both sides and we get -5. So negative 5 is our other endpoint. So D is 1, negative 5. That's the y coordinate was negative 5. All right, so we have one more practice of these. I really suggest that you pause the video and try it first. Okay. All right, hopefully welcome back. And one more time, we want to find the midpoint we already know. We want to find endpoint A has these guys, and we want to know what is B's then. All right, so we're looking for B's X and Y value, the other endpoint. All right, so I know the midpoint has an X value of 4, and we would find that 4 usually by adding up negative 3 plus the other X coordinate and dividing by 2. So I multiply both sides by 2 to get 8. So negative 3 plus X. And then I'll add 3 to both sides, and I find out the X coordinate of B is 11. All right. We'll do the same thing with the Y coordinate. So I know that midpoint's Y coordinate already. The formula to find that would be to take the Y coordinate of both endpoints. One of them is negative 5, and the other one we don't know. And then divide them by 2. So I times 2 to both sides to get negative 18. So this is negative 5 plus y. And then I'll add 5 to both sides to get negative 13. So this means the endpoint y coordinate is negative 13. So our whole endpoint B is 11, negative 13. So recall that the distance between 2 points on the number line is found by taking their absolute value of their difference. We did this earlier in the chapter to find the length of a segment. Find the distance between 2 points on the coordinate plane is a bit more complicated. All right, so you should know a formula for how the sides of a right triangle relate to each other. It's a rather famous one. It's called the Pythagorean theorem. And if you take the 2 short sides and square them and you add them up, you should get the long side. Okay? And you learned this in Math 7 and in Math 8. And we will do it again this year later. And the distance formula for 2 points in a coordinate plane is related to the Pythagorean theorem. We will study all this in chapter 8 when we get there, so you don't need to know how you could take the Pythagorean theorem and turn it into distance formula yet. Okay? But you do need to know the distance formula. So the distance formula between 2 points on the coordinate grid is defined as this. So the points between point A and B, notice we just give them x coordinates x1 and y1 for point 1 and x2 and y2 for point 2. So A and B are points 1 and point 2. And then we could define this as the distance is the square root of the x's difference squared plus the y differences squared. Okay, so like I said, you don't need to know how this formula works or where this formula comes from yet. We'll learn that later, but we just need to be able to work the formula. Okay, so let's try a couple examples here. AB has endpoints at 5, 2, and 8, 7. Use the distance formula to find the length of AB to the nearest tenth. So we'll just plug into our formula. We have the square root of, and that take the x coordinate, x2, so we'll name these x1, y1, x2, y2. Should look a lot like when we name points in slope. And we do 8 minus 5, that's x2 and x1. We're going to square that. Plus y2 is 7 minus y1 is 2. Now, just like when we did slope, it doesn't matter which order you use the x and the y. So you could say the first point is x2, y2, and the second point is x1, y1. Just be consistent in who you put first. Okay. All right, so we work this out. So this will become the square root of 3 squared plus 7 minus 2 is 5 squared. You keep the parentheses on there until you do the squared, because if it was a negative number in there, then we would square the negative and make it turn into positive. So this will become the square root of 9 plus 25. And 9 plus 25 is the square root of 34. Now this is the exact distance. So if I said find the exact distance, this is what you'd write, square root of 34. Remember, the square root of 34 is an irrational number, but we were asked to round that number to the nearest tenth. So this is going to be about 5.8. All right, our last question. Just to practice on this, so use the distance formula once again to find the length. So you might want to pause the video, try it yourself, and then come back. All right, so my distance formula is equal to the square root of the difference of the x coordinates squared. So my x coordinates are 3 and negative 1. And it doesn't matter which order you put them, just be consistent when you do the y's. So I put the -1 first. And then we're going to add on the difference in the y squared. So since I started with -1, I need to start with 10 over here, minus -2. Okay, and then we'll work this out. So this will become the square root of -4 squared plus 10 minus -2 is 12 squared. All right, -4 squared is 16, and 12 squared is 144, and we'll add those up. So 16 plus 144 is 160. So this, again, this is our exact our distance, but we were asked to round. So round it to the nearest tenth would be about 12.6. Okay. All right, I will see you. Oh, and since we didn't know the units, we write unit here. So units, it could be inches or miles or feet, whatever those two things were. All right, I'll see you in class next time. We'll practice midpoint and distance formula.